This is all tipped up. That's younger, this is older. I can see how that works. I can picture that image. But what I'm still struggling with is that I can see it there. I don't understand why it's so abrupt, why I can actually see this line.
Yeah.
You know, how does that work?
Well, the reason you can see the difference between the two layers is that this ice is dustier. It has more dust in the ice than this ice.
Right.
Dusty ice is from cold periods.
Yeah.
When it's colder, there's more dust in the atmosphere, it's windier, and that gets deposited on the ice sheet.
Yes.
And then during warm times, there's more vegetation, it's not as windy, there's less dust in the air. And what we know is that at the end of the Ice Age, climate changed very abruptly from being really cold to a much warmer state.
Oh, I'm getting the hang of it now.
And
So that little bit in there is a couple of decades. And this is the, okay,
Right.
So that's why we can see it.
This is the end of the Ice Age, right there. And the change was not only fast, but big.
Right.
So we're talking about temperature changing by, say, 10 degrees.
Right here.
Yeah. Why it changed is the fundamental puzzle for climate science. Why in the world climate could go through such an abrupt shift from one state to another.
I think it's really exciting talking across you at 15,000 years.
So far, during this current phase of global warming, it's warmed up less than 1 degree in 100 years. But at the end of the Ice Age, it warmed up 10 degrees in a fraction of the time. So could it happen again? To find out, the team are trying to discover what caused the big jump in temperatures at the end of the Ice Age. And they do have a theory. It's all down to a greenhouse gas that's much more powerful than carbon dioxide. It's called methane. Millions of tons of methane are stored in the deep ocean in a frozen form called methane clathrate. Perfectly harmless when temperatures are normal. But if the oceans warm up, the methane clathrate could become unstable. It could turn into a gas and bubble to the surface. And once in the atmosphere, it would trigger a chain reaction. Temperatures would rise further, releasing more methane, accelerating climate change until it was completely out of control. They call this nightmare scenario the clathrate gun hypothesis.
A little bit of warming can trigger sort of a feedback effect where you might get these things start to bubbling and then all of a sudden you release a whole bunch of methane all at once.
And it comes up in huge explosive bubbles, is that right?
Well, that's the notion of the clathrate gun.
So could today's slight temperature rise make the clathrate gun go off? To find out, the team need to discover if it's happened before, for example at the end of the Ice Age. To do that, they're trying to find 15,000-year-old air to see if it's got the telltale methane signature. That ancient air is actually in the ice, trapped in tiny bubbles when the ice formed. And this is what it's all about, melting ice. This is a melter. We put all the ice in there, seal it with a lid on the top, and the guys then draw a vacuum through and it gets rid of all the modern air. At that point they melt it and they can extract the ancient air from the melted water. They end up melting 20 tank loads of ice. Finally, they have enough ancient air to come up with some preliminary results. But no one looks very happy with what they've found.
Well, happens sometimes. It looks like this clathrate gun idea, you know, the idea that large amounts of methane burst into the atmosphere and cause an abrupt shift in climate is probably not what's happening.
Right. So this must be good news because then this clathrate gun, it's unloaded. It's not going to happen.
I suppose you could think of it as good news, but we're also ultimately interested in why did the climate change abruptly?
Right.
And so we're left still with needing another kind of mechanism, and we don't really know what's going on.
So after all that hard work, all Ed can say is that we're probably safe from the clathrate gun. As to whether something else might trigger an abrupt climate change, we just don't know. But But I still want to get some idea of what global warming is going to mean. How warm is it going to get? What I need is some other way of predicting the climate of the future. There is one last possibility that I've heard about. Scientists are now using computers to predict what will happen to the climate in the future. It's the same principle as weather forecasting, only much further into the future. Now, I've relied on weather forecasting for most of my life. When I was climbing Everest a few years ago, it's a matter of life and death. But weather forecasting has had something of a checkered history. Do you remember this?
Earlier on today, apparently, a woman rang the BBC and said she heard that there was a hurricane on the way. Well, if you're watching, don't worry, there isn't.
The 1987 storm certainly wasn't the weather forecaster's finest hour. These days, their forecasts are much more accurate, and that's partly because they've got much more powerful computers. Now, those same supercomputers are being used to try and predict the climate. So what have they got to say about how warm it's going to get in the future? Well, it's actually very confusing. I've found lots of predictions, each one made by a different group of scientists using a slightly different computer model, but they never seem to agree. This is the most authoritative forecast I can find. It's from the UN panel set up to study global warming. It's looking at the climate for the next 100 years. And it says here that the world could warm up anything from about 1.5 degrees to about 6 degrees. That seems like a massive range. Getting it right matters. 2 degrees is the critical level. If the climate warms more than this, it'll trigger all sorts of irreversible changes, like the melting of the Greenland ice sheet. Yet the models can't say whether we'll cross this threshold. I want to see if there's any chance of improving this prediction. Surely there's got to be a way of making it a bit more precise. So it's off to the green for a spot of golf. As well as enjoying the odd round of golf, Tim Palmer does weather forecasting and climate prediction for a living. Apparently this is the perfect place to show how it might be possible to make a better prediction of future climate.
Okay, so let's start talking about short-range weather forecasts, so maybe a few days ahead. So let's imagine this is like putting the ball up to the hole.
All right.
So here we are.
Okay, this is our forecast.
This is our forecast,
all right.
And we'll see what happens. Okay, and whoa, pretty close.
Close.
Okay, pretty close. So we'll do that again. Okay, and so it's just missed. But you can see the balls cluster around the hole pretty well. And we'll just do a third one.
All right.
And, whoa. Okay, look, the inaccuracy, if you like, is pretty small at this range. In fact, it's so small that even you could have a go and try and get...
Come on, let's have a go.
Go on then.
This is going to show that even an amateur can produce a reasonably accurate short-term forecast.
We'll see. Now, keep your head down. And,
yeah, a few tips would be handy.
That's right, and give it a good bash. Whoa! Straight
Piece
in
of
the hole.
cake, short-term
Straight in the hole.
forecasting. The point is that because weather forecasting only has to look a few days into the future, it's relatively easy to be pretty accurate. All the forecasts are about the same. But then Tim introduces me to the T, to take on the problem of forecasting climate years into the future.
Okay, well, that's pretty good. That's gone fairly straight.
Yes.
But let's try it again.
Each time Tim hits the ball, it's like a different computer model trying to predict the future climate. Each model is slightly different, just as Tim's golf swing is never exactly the same. And because the models are trying to see so far into the future, these small differences have big effects. That's why the various climate models don't provide a consistent answer to how warm it's going to be in the future. So I'm getting the idea now that small changes here, they're going to have a big effect when it's way out there.
They're going to have a big effect.
And that's even with you as a skilled golfer.
Well,
The climate models at the moment, the computer models, can't give us a range any tighter than that big range we're seeing right up there, this 2 degree, 6 degree. We can't get that any tighter with the existing model.
but we can deal with this problem to some extent.